management and all the people behind the organization of this specific conference or workshop or whatever you can call it. And hopefully from the past few sessions, I understand that you would have got some good amount of knowledge in the specific area of this specific conference. So today I'm going to talk something about artificial intelligence and how it is being used for the biological concepts. An interesting word, an interesting phrase, right? But how much do you understand the background information on AI is very crucial in determining the success of your work with specific artificial intelligence approaches. So the next 1.5 hours or so, I am going to be with you and give you a variety of information right from the scratch till the advanced concepts. Let me share my screen. Madam, it says host disabled participant screen sharing. Can you grant permission?
Pardon, sir? Pardon, sir?
When I try to share my screen, it says host disabled.
Yeah. So, sorry, sir. I'll make you host.
Okay.
You can share now, sir.
Is my screen visible?
Yes, sir. Yes.
Okay. Hopefully now you can see the big screen.
Yes, sir.
Okay. So the topic I have chosen for today's discussion is natural intelligence versus artificial intelligence, the role of deep learning in biomedical applications. As from Dr. Sivashankari's information, I understand there are student participants and also people in the advanced stage of your career. So I thought maybe I will start from the scratch and go till the application parts. If you carefully observe, I have given 3 colors for my title, where you will have part 1, part 2, and part 3. Depending upon the level you are in, you can grasp that amount of information. And if you want to go further in detail, you can connect with me offline, or you yourself can explore lots of information from the internet. So this is all about me. Dr. Sivashankari has already given detailed information about me. But suppose why I have all this slide is specifically for me, not for the participants, to make sure to have a self-check on how I move forward in our research career. I am not very sure how many professors or academicians are on the other side. But if somebody is there, always try to have some self-evaluatory tool to check how you proceed in your career. If not, we will always attend workshops and seminars, but we will never put all those into practice. Right? So these are some information I always check whenever I go for a seminar or webinar. I try to check what are the possible increase in the contents of this specific PPT slide. If nothing, then it indicates that I was sitting idle for the past few months, which is not at all good for any academician. So I'm in the editorial positions of many journals. Suppose I'm not sure how many of you are working in this area. If you are in, you can always let me know if you need any support in that specific way. So the agenda part 1 is origin of artificial intelligence, specifically the theological aspect of AI. One who is not at all heard about the word AI can take out this part 1 so that they will understand how this AI came into existence in this world. Second one specific subset of AI is deep learning. Currently, maybe for the past 5 or 10 years, if you carefully observe the research in a bio domain, be it biomedical, bioinformatics, or biotechnology, people are continuously using this methodology called as deep learning. So I will be taking this deep learning and specifically one deep learning model, which is called as convolutional neural networks. Maybe you would have used in your work, but how much do you understand? That will play an important role in developing modified deep learning models. So whenever you attend some seminar or workshop or any guest lecture, you need to understand the concept from that, and then it is your duty to develop some modified or innovative algorithms or methods or process. So that is the way how we have to grow. And part 3, I will talk about the application from the bio scenario. From the bio scenario, how people are using for the biomedical data analysis. So let us start with the origin, the part 1 part, the theological aspect of AI, how this AI came into existence. So if you refer the literature, artificial intelligence, the word artificial intelligence is invariably given different phrases. They call it as machine intelligence. They call it as computational intelligence. So all these corresponds to some effect of artificialness. Say, for example, you prepare a kesari in your house, right? When you prepare kesari, sometimes it is yellow in color, sometimes it is red in color. If it is yellow in color, when I ask my wife, she says that we have included pineapple essence. It's not real pineapple, but it is the artificial flavor. Not only in kesari, you take any ice creams or any foodstuffs, we call it with all the real world information, but which is not actually there. So the idea is, whenever we say intelligence, right, which is artificial in nature, there is some intelligence which is natural in nature. And this AI or artificial intelligence is derived from that natural concepts. So you must have a good understanding on the natural concept. Only if you know the taste of pineapple, then you can make a pineapple essence. So it is very, very mandatory to understand the natural concepts. In other words, I can give you both together in a single frame, how natural intelligence and artificial intelligence differs. So natural intelligence, it's very easy, right? The creation by God of human beings is always, we call it as natural stuff. When God created human beings in this world, as per Christian ideologies, we say that he created in 2 steps, right? First, the human body or the structure is created with mud and clay. Possibly, God would have expected that mud and clay structure to interact with him. Now the question is, what is the purpose of God creating human beings? That is a debate for another session. Possibly we can meet face to face someday. But for the time being, you understand God created human beings with mud and clay. But he did not interact with God. Only then he realized he is just a dumb mud and clay structure. Then he injected life into the human body and human being came into existence. That's why we say all our human beings are made up of something which is visible. Somebody's joining. Something which is visible to other people. You can see me, you can see my eyes, hands, all those things. If you just want to make an operation with me, you can see the internal parts too. But what you cannot see is what I am thinking now. What is my emotional feeling now? What is my character? What is the soul or the mind, the inbuilt life which is there? Theologically, maybe you can call it a soul, which is not visible to the outside world. So from that part, the concept of intelligence came into existence, right? If I feel hungry, automatically I take some food and eat. How do I do that? Right? I was trained when I was a small boy. Whenever you are hungry, you should not drink anything. Instead, you should eat something. How do I do that? Nobody knows, because it's God's creation. So he created not only the natural stuff, but also he injected the intelligence for living in this world. Right? So this is the process which happened maybe long back, 60 years back or 100 years back. Human beings, they had a desire. If God can create something, why can't the human beings, we create something, right? But interestingly, we cannot create anything with blood and flesh. That is the natural phenomenon. We cannot do that. We cannot recreate that. But we have the artificial engineering stuffs. We have iron, we have aluminum, we have steel, plastic, all those materials are available. Then he thought, let me create a structure. That structure is called as machine, which is going to be artificially created by a human. Why I say artificial? Because it is going to be a replica of the human being. Again, he is not happy with the dumb structure. He wants that machine to independently live in this world. I am not sure whether this desire is good or bad, but that is the desire of human being. So what he does is he started injecting life into that machine. But that is not a simple process. We may read and find out that God created human beings in maybe within 5 minutes or 10 minutes, we can do that. But only when you put hand into that, you can understand the beauty of God's creation, how difficult, how complex it is. And now the methodology or the techniques which we are studying is all about God, what God did long back. We are trying to duplicate that. So an artificial machine which can live independently in this world is the objective of artificial intelligence. So this is the hierarchy from God, humans, and from humans, machines. So the idea is making a machine is not that difficult, but giving life, the hidden agenda. You can see my hand, then you can replicate that. But my soul, my emotion, is very, very complex. Only then I can live independently in this world. How I am going to incorporate that? Still, human beings are moving forward towards that. So what is this intelligence? What is this intelligence, or what is this natural intelligence? It's the ability of human beings to take decisions when he or she receives a stimulus or an input. Say, for example, suddenly a snake enters this room where I am sitting. What will I do? I will not wait for you people to give some information. I will try to find a way by which I can be safe or run out. So simply, I am not going to take a decision, but whenever I receive a stimulus or an input, I am going to make a decision. So whenever we say decision, it is not about where to study, which job to go for, where to buy a house or whom to marry. It's not like that. Each and every decision you take. Now I received a call in my mobile. I am not picking up that call. Why? Because I am in another duty. That is a decision. So when do I take that decision? Whenever I see my mobile, whenever I receive some input, I take a decision whether to go or not. Each and every second of your life, you are taking decisions. Even now, if you are looking at the screen and listening to me, it's your decision. If you are doing some other work, again, it is your decision. Now, what are these inputs? When you take our human body, we have so many organs, right? We say kidney, brain, liver, all these are very, very important. Yes, of course. But more than these organs, there are some organs called as sense organs. We would have learned in our kindergarten classes, right? Eye, ear, nose, skin, tongue, and all those things. These are the organs which are an interface between human body and my external environment. Just assume one day all these sense organs are shut. What will happen? Even though you have brain, heart, kidney, lungs, everything, you will be completely cut off or shut off from the external environment. You cannot make any decisions to live because you are not receiving any inputs. Right? So these inputs which we receive are actually called as data. In engineering terms or technical terms, people call it as data. That is nothing new. That is derived from the human body. And they call it as images or videos. It is related with eye. Audios, it is related with ear. There are other set of data called as temperature, pressure, which you can feel. You cannot see, you cannot hear. Right? But if you are in an AC room, it will be chill. If you are in a normal room, it may be hot. So that is given in terms of numbers, which we call it as a numerical data or a text data. So these are called as analog inputs or raw data. When these inputs reach our human brain takes a decision. Now, when I'm going to form an artificial human being, I need to supply this data and make the machine take a decision. Once I do that, after some years, automatically it will become self-independent and it will live in this. This is the main objective of artificial intelligence. But interestingly, there is a checkpoint. Why did I say it is very complex to give intelligence? Because we are not completely comfortable with the function of human brain. Human brain is going to take the decision in human body after receiving the inputs, but God has given a checkpoint. Right? We are unable to completely explore that what is happening inside that. And that's why till 2022, we are not completely framed a full-fledged AI. We can hear news about Elon Musk, China doing, Korea doing some information, or forming something, creating some structures, but they are not a full-fledged artificial intelligence. One day, when man or human race completely explores the human brain, then definitely there is a high chance that an artificial human being will exist in this world. So these are some unsolved questions by the scientists. Why does a 6-month-old baby cry when he or she is hungry? Just to attract the environment. But why does she cry? Why not laugh? Or why not do something else? It's God's creation. How do you find your way home from your university? First day, I asked someone, where is the ECE department? Where is my cabin and everything? But next day onwards, I automatically go and come back. What happens in my brain? Still, it is being explored, not completely understood the information. So one small information about the data. When I talked about the data, there are different types of data. Among them, images are very, very important. Right? Why images are very, very important? They play a crucial role in making the brain take a decision. That's why when your eyes are always open, even if you are not concentrating on something, some information is captured by eyes and it is given to the brain. So brain has to continuously work. If the brain needs to take some rest, there should not be any information passing on through our eye. That's why whenever we feel sleepy or drowsy, automatically our eyes will close. There is a shutter for our eyes which close our eyes. God knows images are very crucial and it is going to help the brain take a decision. Now come to the second one, signals or audio or speech. Our ears. How many of you sleep with your ears closed? None of us do that. Why? Even if somebody is making a huge noise, still we can sleep. That means the noise which is entering through your ears doesn't have much impact on your brain. That's why brain can still take rest even when signals or audio or speech is coming through your. Just to tell you the importance of images than other data. That doesn't mean other data are useless. Our human body should work in unison. So all the data are important. Now come to the concept of AI. So when you say AI, now you must be in a position to understand what I'm going to talk about AI. We cannot go into AI directly. We need a structure. That's why people say hardware and software. Right? The external part can be manufactured. That we call it as hardware, electronics, instrumentation, or other different types of mechanical or anything. Everything can come into picture. But the internal intelligence, can I live independently? That should be incorporated into the structure, which can be equalized to the concept of software. That's why computer science play a major role in any artificial intelligence methodologies. But application-wise, all are using it. But if you want to understand, you need to know some computing terminologies is equal to your artificial life. So this is what I am going to, or I am trying to take care of. So these are the different branches which can be involved in creating an artificial life. Suppose if you're from an arts and science background, still you have a plenty of scope or opportunities in this specific concept of AI. You can explore that, or you can ask me later where I can let you know. So the process of providing decision-making skill to the human being is AI. Now leave out the external structure. So till now, I was concentrating on external structure and the intelligence. Now from this slide onwards, I'm going to talk about only the internal phenomenon or intelligence. How can I give an independent decision-making skill, which can behave or which can move without the support of human intelligence? Most of you would have seen a movie or the entertainment industry where nowadays the villain is not a human being. Right? The much fancied AI is gripping also the entertainment industry, where we have always an artificial human being portrayed as a villain. So these are the different parts of AI. So when I say AI, it is the complete picture of giving intelligence. How can I give intelligence? Maybe via images, maybe via text, maybe via signals. Many groups are available. Based on that, these are different components of artificial intelligence. Knowledge, reasoning, or representation. Right? How do you represent the data? You cannot show a banana and teach the machine that it is an apple. Right? So representation of data is very, very important. That's where ethical issues of AI also come into play. People ask me, you create an architecture, you create an intelligence point, and then you make it use for them. If my thoughts are bad, the work which the machine also will do, the work the machine will do also will be bad. Right? The ethical issues, the vulnerabilities of AI and ML is also planning and searching. All the data which reaches my brain is not necessary for decision making. Now you can hear me, you can see me, you can feel the temperature of your room, to which you are giving importance. Possibly my audio. You are not giving importance to your room temperature, neither my image. Right? So similarly, you need to search and plan. When I have a huge amount of data, we call it as big data. Go to Facebook, LinkedIn, or any social media websites. The data available is huge. So when you have a huge amount of data, whether all are necessary or something is sufficient, that you can decide. Natural language processing. Now people talk about virtual reality. Your professor will not come to your class. Your cloned professor will come to your class and he will talk in the same language. With this COVID situation, I can take class for anyone from other countries too. I do that. But now they should understand English. Suppose if there is someone from China or some countries who have some difficulty with English, then NLP will come into play. computer vision. If you incorporate intelligence via images, then we call it as computer vision. These are broad oceans, right? Completely different areas. If you want to be an expert in computer vision, then possibly you may not be that expert in NLP. That's why only when all the people come together and do some work, we can make the artificial intelligence a reality. Then we call it as brain-computer interface, right? We have a human brain and a computer. How can you put all that in your head into a computer? Can we recreate our dreams? Right? Normally, we have dreams when we sleep. Morning, when we get up, we may forget 50% of them. How it will be when you switch on your video and look at all your dreams? Brain-computer interface, another excellent area. And another important area is machine learning. How do you train the machine? Right? So in this session, I am going to concentrate on point number F, not on the other things. They are different topics on machine learning. How can I incorporate or train the machine so that it can take some good decisions? So there are three types of artificial intelligence, to be frank. What we are in is called as the first stage, or stage number 1. When I was doing my BTech, maybe 20 years back, people told me that there will be an artificial human being in the world, but it is now 2022. Till now, I cannot see any full-fledged AI human being walking on the roads. People say in China, there are some, in Japan, but it is not up to the mark. So we do not know when we will reach stage number 3, which is called as the super intelligence, where your machine will become far, far superior than human being. But understand, in 2022, we are still in stage 1, which we call it as machine learning, where that machine is still inferior to human being. It can do only one operation at a time. An algorithm or a method which is doing operation for one application may not be good for another application. That's why I say that it does only one operation at a time. We are trying to move towards stage 2 and stage 3. Possibly other Western countries, some advancements are there, but maybe, I'm not sure whether God will allow that or not, we may see stage number 3. So we are going to talk about stage number 1, it's called as machine learning. So as I told you, machine learning is the process by which we make the machine learn. We give some data and ask the machine to store in its mind, and then try to recollect the data from that machine. That is where how a human being behaves. Right? When I go to Delhi, I visit Taj Mahal for the first time. So all the appearance I just grasp in my mind. So when I come back, I just share with my friends. So this human nature is being used to train that machine also, which we call it as machine learning. You must have heard about Alexa. Some people may have in your home, or if you are using an Apple iPhone, you must have Siri and all these personal assistants, which are based on machine learning. It has been already trained, right? We train them. We show them banana and say, this is banana. Whenever you go to your shop, we tell the machine, whenever you go to the shop, whenever you look a long curved yellow color object, it is banana. Once you train the machine with all the information, definitely it will take good decisions and it will live independently. So now I'm going to a bit deeper to the part 2, where I am going to give the background information on the machine learning methodologies, how the concept of machine learning came into existence. Right from 1940 till 2010, people are trying to give this process of training to the machine to store the information within the machine. How do I store? I have brain. So whenever I was a boy, I could see many things. If you observe, small kids will be always enthusiastic. They will ask why, what, just to store in their mind, because their mind is completely free. Their brain is empty. Same way, the machines should be also made to learn, or they also should be trained. So we started with electronic brain in the year 1940, and there was a sequence of changes, right from 1940 to 2010. And in 2010, we are using one important machine learning technique, which we call it as deep learning. So artificial intelligence is the broader umbrella. Under that, we have machine learning. Within machine learning, we have this concept of deep learning. All the researchers, all the academicians are using deep learning now. Before deep learning, we had another concept called as artificial neural networks. So whenever there is a new technology, you must ask a question, why? You must first look for literature where you will be able to find out why deep learning, why not something else. For that, you must compare that deep learning with the previous version, something like Windows 11 and Windows 10. Only then you will understand how Windows 11 is going to be useful. The same way, let us have a small comparison between the yesteryear technology, artificial neural networks, and deep learning. Deep learning is the advanced representation of artificial neural networks. The word deep in deep learning corresponds to more layers. What do you mean by layers? You can look at architecture, right? So this is the architecture of an artificial brain. I have two architectures showing. I'm showing here. The one on my left-hand side is the normal one, or we call it as artificial neural network. Network means connection. Neural means neurons, right? Which is the part of human brain. Artificial means I have created that. Now, when you look at your deep neural network or deep learning methodologies, you can find that there is plenty of layers. What's a layer? A column-wise arrangement of neuron is called as a layer. You have input layer, you have output layer, and plenty of layers within them. So what is the beauty in increasing the number of layers, right? So in 2010, they found out if I increase the number of layers, any application is going to give me a better decision, or my accuracy of that application will be very high. This is the idea behind increasing the number of layers. More number of layers means more accuracy. How do I say that? You can refer lots and lots of research papers, maybe for students, research papers may be new, but maybe if there are some professors, when we come to part 2, we need to enter into the research arena. So more number of layers means more accuracy. However, the normal artificial neural network or the backpropagation neural network, which we can call it as, is not suitable when I increase the number of layers. So this architecture, which I'm showing you now, if I increase the number of layers here, I am not going to get good accuracy. But what is the difference between these two? Architecture-wise, you may not have much difference, but the way in which you are going to train the algorithm or methodology or make the machine learn, training and learning, both are same, is going to be different in deep learning or deep neural networks. So deep is the word related with architecture, and learning is the word related with the way in which you are going to store the data. Both are different when you go to the deep neural networks. Because it has the provision for more layers, it has become, it has given more accuracy for the applications. So people left artificial neural networks and they entered into the concept of deep neural networks or deep learning. So let us take an application. This is the second, the first one is in terms of architecture and training algorithm. The second point is from the application point of view, pattern recognition, right? Whether this is a brain image or a lung image or if you are from bio, some other bio background, whether it is so and so or whether it is something else. How to identify that? A human being can easily identify. This is a mobile phone, this is a laptop, this is a water bottle, and also all other things. But if it is a machine, how it is going to identify? That process, we call it as pattern recognition. Say, for example, you take the simple application of digit recognition. You can easily say it is 0 to 9, but you have a machine. And the machine should identify that this is 0 to 9. How can it do? We have a block diagram. Most of the researchers, if you have already worked in that, you must be knowing this. You have an input database where I will give all the numbers, and if there are some noises, I will remove that using pre-processing. Then there is a crucial block called as feature extraction, where I convert my real-time input into numbers, because the recognition block where I'm going to have my algorithm or my deep neural network is going to be a computer. I cannot paste any image into the computer. Can I do that? How will I give an input to the computer? It should be given in the form of numbers, right? So what I do is I take the input, convert it into numbers, and then give it to the machine. Now, when you go for deep learning or deep neural network based pattern recognition, what will you do? Is the block diagram same? Almost same, except for one specific phenomenon. You do not have a block called as feature extraction. This is a simple thought of a student under Professor Hinton in University of Montreal, Canada. He thought, let me remove the feature extraction block. Then you may get surprised. Then how will I give the input to the computer if it is not converted into the form of numbers? Right? Whenever I say there is no feature extraction, I am saying that there is no manual feature extraction. In the previous block diagram, I am going to extract the features. Who is going to give the input? I am going to give. Who is going to do the noise removal process? I am going to do. Who is going to do the conversion? I am going to do. Then I give it to the computer or the machine for recognition. But if it is a deep learning or deep neural network, I am not going to dependent on manual feature extraction, but instead I am going to dependent on automatic feature extraction. That's why I am cutting or striking down the feature extraction block. Whenever you have a block diagram, the content within each block is showing some process. Normally, students come for our project work. They display a block diagram, but they will not show the process going on in each block, right? So when you have a block, it indicates that there is some process going on. So that's why in deep learning, when there's no process, we are going to mix feature extraction and recognition together. The deep learning or deep neural network, which is there in the recognition block, is going to do the duty of feature extraction too. Now the question is it really necessary? Why should we go for that? Or I can ask, what are the advantages of eliminating manual feature extraction process? The first one is the necessity for expertise can be avoided. Say, for example, if I ask someone to differentiate person A and person B, whom you have never seen, how will you differentiate them? I am giving a clue that he is a professor. Then you may think that the professor may be old, maybe white hair, some belly, some specs, all those things you would have imagined, which is actually wrong. So your expertise is not sufficient to differentiate a person unless otherwise you know some information about them. Can you write a sentence in Greek language or in French? Some people may know that, but on the understanding that most of you do not know, right? then it is not possible to give them or provide a correct feature. Another important aspect of feature is it should be characteristic feature. It should be differentiable. Say, for example, you are differentiating apple and mango. Apple is red in color, mango is yellow in color. Apple is a bit hard, mango is juicy. These are the characteristic features. You cannot give a word called as fruit and ask the machine to differentiate between apple and mango. Then it will get confused whether I should go for apple or mango. Right? So the necessity for expertise when you go for manual feature extraction can be avoided in deep learning. Why? Because you are not going to do the feature extraction process. The system itself will take care of that. And as a result, because human beings are prone to make mistakes in feature extraction, now when your methodology is good, when you go for an automated feature extraction, we say that more chance of accuracy. You will get a better accuracy when you go for deep learning. This is the main reason why people are moving towards deep learning for bio-related applications. Because medical applications, your accuracy is very, very important. You cannot take chance. So give the responsibility to the algorithm itself, to the method itself, which can give very good results. So a small example for you. Say, for example, this is a digit recognition system, and I am taking vertical line as one of the feature on the hope that only one digit will have vertical line. But what happens? 1 has vertical line, 4 has vertical line, 9, 7, everything has vertical line. So when I give vertical line to the machine as an input, it will scratch its head and it will try to find out what is exactly the digit, but it may not be possible. It will make mistake. The decision making, the intelligence will go wrong because the way in which you are giving the data is wrong. Now look at horizontal lines. 0 can have horizontal line, 2 can have horizontal line, 4 can have horizontal line, 5 can have horizontal line, 7 can have horizontal line. Right? Again, more than one digit. Again, the machine will get confused. Small circles, 2, 6, 8, and 9. Anything can have small circles. Again, when you are not an expert in that specific data, the feature you are going to extract is going to be wrong. When you are extracting a wrong feature and give it to the machine for recognition, definitely it is going to take only it is going to give you only low quality results. That's why ANN was giving very low quality results. Once that problem is tackled, once the responsibility is given to the system, now all the applications have seen a tremendous increase in their accuracy or performance. Later, we will look at some of the applications and then we will know how it is going to be useful. So these are the different types of deep learning approaches, and in that we are going to concentrate on one specific approach, which we call it as convolutional neural network. If you have already published some papers with images, definitely you will have come across this word CNN, right? But if you can understand what happens in the background, which I'm going to give you now, it will be very much interesting and useful for you to give in a better way. Again, need for CNN, how we saw whether deep learning is important or not in comparison to ANN. In the same way, we also must find out whether CNN is really necessary or not. So for that, I am going to compare it with the primitive or the previous network, which we call it as a feed-forward neural network. So that network has a drawback. How ANN has a drawback, we went to deep learning. In the same way, within deep learning, there are many methods. CNN has some advantages in comparison to DFNN, or in other words, DFNN has some drawback. What is the drawback? Take the same case study. Assume I have a DFNN. Now this is an algorithm or a program within a computer, which I'm going to call it as a machine. Right? Assume that I have a machine with a DFN within it, and I have trained it to recognize digit 8, right? And I have given the data 8 and 5, and that machine clearly identifies that this is an 8 and this is not an 8. Very good. Now, after 20 minutes, I am giving this second set of data. Again 8, again 5. Now, when I give this 8, the same machine which recognized that it is an 8 20 minutes back, now it is feeling confusion. Why? And it says no idea. And when I give 5, it is asking me, what is this? Now, what the human user will do? He will scratch his head whether the machine is working or not. Now, what is the difference between these two? The first data, we have the region of interest in the middle. But when you look at the second data, we have the region of interest in some corners, not in the middle. So what do you understand from this? DFNN model or machine or algorithm can correctly identify the data only if the region of interest is in the middle. If it is shifted to corner, it will not be able to do. We also call it as position sensitiveness. How can we solve it? One option is you can write 8 in all different angles, right? How many angles you have? Infinite. Is it possible practically? Not at all possible. How many sizes you can write? Plenty of sizes again. You may say that I can make all these different things and give it to the machine. Already the machine is having more layers. That means more complex. Now, when you supply with more amount of data, instead of a single data, it is going to make, or it is going to suffer from computational complexity. Medical applications or bio applications cannot wait. We need to give the decision quickly, right? So it doesn't make any sense. If you are from computer science background, you may say that I have the supercomputer from NVIDIA or GPUs, which can solve quickly, but still the question is out of the equation. When I am sitting, my name is Jude. When I am walking, my name is Jude. How will my name change when I change my position? Does it make any sense? No. So whether it is in the center or in the corner, my machine should be in a position to identify whether this is 8 or not. Right? For that, I need to go for another process called as convolution. So when I mix my convolution with this neural network, I can say that my deep learning is going to give me good accuracy. So CNN is not anything new. You have the artificial neural networks, the conventional one. To that, you are adding one more part, which is called as convolution. When you mix convolution with your normal neural networks, you can say that the system itself can extract the features and the accuracy is going to be very high. We will look at that a short while from now. So what is convolution? This I have taken from Wikipedia. It is a mathematical operation which is used for any processing between two functions. So you have a original bio image and you will have a duplicate image. You need two functions. When you convolve these two things, you are going to get a third image, which is called as a modified version of one of the original image. So when I see modified version, I think maybe the position may be changed. So instead of myself writing 8 in different position, if I use convolution, it itself will give the original image in different versions so that my machine can take a better decision. This is the main objective of going for convolution. Now let us take a simple image. You can see a small boy sitting in the middle of the garden. Now, how can you, or how the convolution is going to work on this image or this input data? Assume the boy is not sitting in the middle, right? So the machine is having some confusion. So when I use convolution, what I'm going to do is I am going to derive many different modified versions of this original image. How do I do that? I do something like this. I cut this original image into many small images, right? So when you look at the images, you look at the sixth image. This is one small image. When you look at the sixth image, the boy's head is on one corner. Next image, it is in the middle. Next, it is in the corner, left and right. So you can see the body of the child available in more than one position. DFNN could not do that, but convolution is able to do that. So this specific process is able to split my original image or data into many small sub-images, by which the machine will get a better understanding. Instead of seeing only this center part, if it sees more than one human body part, it will easily say a child or a human being is sitting in the middle of the corner. This is what convolution is going to. So let us see the complete convolutional neural network. In the process, you have an input image or an input data where you need to identify some something based on your application. Here we are saying that we want to identify the child. So you have three stages in CNN. First one is convolution, as we saw just now. The second one is called as max pooling. And the third one is our normal neural network. That's why if you want to jump into deep learning, definitely you must have a good understanding on artificial neural networks, because the last stage or the final step of deep learning is only artificial neural networks. Let us see how the convolution does, how the convolution is able to split an image into many small segments. Now look at this image. What we see? Dogs. But what computers see is only the numbers. I am not sure if you are good in images. When you see an image, each image is divided into smaller parts called as pixels. Right? Each pixel will have a value. That value or number is the only thing the computers would see. Right? Now I am going to play with these numbers and determine the convolution output. What is the convolution output? I want to break this huge image into many small segments. How I am doing that? Let us assume an input of size 32 cross 32 cross 3, 32 rows and 32 columns. Right? Look at this matrix. 32 rows and 32 columns. And this 3 corresponds to the color of the image. If it is a color image, you will have red, green, and blue. Then we say it is a 3-colored image. Or you have a gray level image, which may be much more simpler. Assume you have a RGB image. Now, how the machine is going to identify that dogs are in this picture? We will take an analogy of our real-time situation. Assume that I am left out in a dark room. There is no power, no tube light. I want to search for my pen. What will I do? I cannot do on my own because there is no power. I will go out, take a torchlight or a flashlight. I need a support, right? So remember that convolution needs the original image and a support, duplicate image. So now I am taking a support, flashlight, and I am entering the room. What will I do now? I will simply switch on my flashlight and show it to one portion of my room. Now assume the room is the complete image. As a human being, I am searching something within the room. When I switch on my torchlight, that means I am overlapping my torchlight on the wall. A small portion of the image is visible. What is that small portion of that complete room? The small sub-segment of the first image. This first image is the first portion where I'm showing the torchlight. If it is not available there, what will I do? I move it to the next position. My torchlight size is very much smaller than my room. So the amount or information which is visible to my eye is also very less. Likewise, when I go throughout my room, what happens? I can get the complete information of my room. At one point of time, I will find my pen. So this is what happens in convolution 2. You take your original image and you take a duplicate image. That flashlight or torchlight, you took it for your support, can be called as a tube light, can be called as a duplicate image, and which is also an image of size 5 cross 5 pixels. Understand that the size of the duplicate image is very much lesser than the original image. That duplicate image, technically we call it as a filter. If you have written some code in Python on CNN, then you would have come across this word called as filter. So when the filter is overlapped with the original image, there will be some processing by which I'm going to get only a small portion of the room. What is that processing? Each filter parameter, it is also an image. It will also have some value. So that position values will be multiplied and added with the original value. So when they are multiplied and added, and when it goes throughout the complete room, you will get a multiple values, right? For one position, when you multiply and add one number, but when you go on throughout the room, you will get many numbers. Say, for example, if you go for 784 single positions, then when you convert it into a matrix, it will be a 28 cross 28 output image. So similarly, suppose if with a first torchlight, if you are not able to find your object, you go out, take another torchlight and come back again. So the output depends upon your torchlight, depends upon the intensity. That's why selection of filters is very, very crucial in your convolutional neural networks. So now this is the output which you can visualize. This is the original image, and these are 10 small images. Each rectangle corresponds to one small output of this image. And you have 10 small images. That means 10 torchlights I have used. Technically speaking, 10 filters I have used. And each time I have used a filter, I have got a small output. Now, what are these things? Why do I split my original image into many small images? Or why do I use convolution to split that? The idea is you can see small information from the image. So if you carefully observe, you can find out the front portion of the car here. That means what? These images or small images are nothing but features. Now recollect my first slide, automatic feature extraction. I did not extract the feature. I just gave the car as an input image, and the convolution layer itself divided or split the original image into many small segments, and from each segment I can have a rough guess on what that object is. That's why we call that as a feature or feature descriptor. Now I'll give you a small example. Say, for example, the original image is hidden from you. This is the filter I have used, and from the with this original with this filter and with that original image, I have done a convolution and I have got an output like this. I am talking about an animal. Can anybody guess what that animal could be? Any rough guess? Maybe quickly you can unmute your mic and let me know. I will repeat once again. I have an original image of an animal, and to that original image of an animal, I am convolving or doing convolution process with this filter. When some overlapping takes place, some portion of the room is visible. Some portion of that animal is available here. Can you guess? Can you find out what this animal is? Any rough guess? No? Okay. This animal is a cow, right? This animal could be an elephant. This animal can be a giraffe, or this animal can be a mouse too. What I am trying to say is, when you use one convolution layer, you are not able to identify the object, even though you have extracted some features. Now, can you correlate it with the previous slide information? More accuracy means more number of layers. Only when you increase the number of layers, the number of features what you will get also will increase, and there is a better chance of a decision making that this is a rat. When you show to a specific portion, say for example, the pen cap is visible to me. Now what will I do? Then I slowly try to move close to that pen cap with an objective that I will find the pen. Same way, when you have more layers, each layer will move from this specific line and it will find out the continuous portion or region. And when I come to the last layer, I will have a rough guess on what is that object. That's why deep learning or deep neural networks are more accurate. These are called as low-level features, which are not sufficient for taking a decision. How can we solve it? When we go for more number of layers. Increase the number of layers, 2, 3, 4, 5. Some of the recent machine learning methodologies will have 100 or 1,000 convolution layers too. They are extremely complex, but they give good results. So it's like a high-level feature process. You have a single line. From the single line, when you get a square, then there is a better chance of recognizing. It may be a laptop or it may be a table or something like that. So this is the way how a deep learning is able to recognize or make a decision on the information content in your original input. So now the question is, again, as we saw that earlier, all the input information is not useful. That is how human beings are living in this world. In the same way, I have extracted 10 images, right? All the 10 images may not be useful for my process. If I use all the 10, nothing wrong. But what happens? The time consumption will increase. So what can I do? Remove the images where the region of interest is not there. Do you remember that child image, which we divided into 77 small images? In the first 6 images or sub images, there is no body part of the child available. Only on the 7th image, the body part of the child is available. So once if you take the 7th, 8th, and the necessary images where you have the body part of the child, you will get better accuracy. At the same time, it will be quick too. So this step number 2, which we call it as max pooling, is used for reducing the unwanted features, unwanted sub-images, which the convolution layer is providing you. We have a process for that, which we call it as downsampling, where from 4 images or 10 images, we are going to pick one. So 1:4 or 1:10, depending upon the user, you can narrow down on the. And step number 3 is our fully connected artificial neural network. So the complete architecture will look like this. This is the original data. This is the convolution layer. This is the max pooling layer. Put together, we call it as feature extraction. Right? Who is doing this feature extraction? Not me. The system itself is doing the feature extraction. That's why it is more accurate. Once the features are extracted, I am coming back to my original method where I'm using an ANN for my classification. This is how a CNN is working on. We have many softwares to implement this. If you are good in Python, you can make use of Python. It doesn't mean that I am a commerce student or I am a bio student or anything. You can easily get into that, get your hands on this, and then when you mix these methods and with your bio applications, then there are plenty of opportunities and scope for students as interns or maybe getting a job in a company, in an AI and ML company, which is going to pay you more than any other jobs. If you are a professor, your research output will be well recognized in the outward world, outside. Requirements, you need a high-end processor, a good quality computer, not a laptop, may be necessary. But if your institution can support you, it is not a big issue. Now let us come to the last segment where I will show you some applications which we did with this type of deep learning methods. The first one is COVID-19 detection from lung images. All these are bio applications only. I have skipped the non-bio applications, but if you are interested in that, you can let me know. I will give you some information on non-bio applications too. How can you identify COVID-19 from X-ray and lung images? Right? So only the serious patients will be asked to take an X-ray and lung images. Say, for example, for the current scenario, you may ask me, sir, he's going to die. Is going to be a fatal decision is going to be soon happening in that specific. That may be true, but later on, COVID-19 is going to be with us for years to come. So later on, after 20 years, when a patient is suffering with the symptoms of COVID-19 and TB, you need to differentiate. Otherwise, you will face serious issues. So this approach is not only used for the current scenario, but also for the future. So the first thing you need is your input database. As I told you, data. Without data, you cannot do anything. So where I can collect the data, go to this web link where you can easily download plenty of data. When I was doing my work 2 years back in 2020, we could collect 360 images because that was a very new time. But I am very sure now you will get thousands of images now. You will have COVID-19, SARS, and pneumonia too. You have CT images and X-ray images too. Depending upon your interest, you can take. Now, if I don't give the names below, COVID-19, pneumonia, and SARS, you will not be able to identify which one belongs to which, right? So the problem is complex. So only for complex problems, we need to go for deep learning. If your problem is simple, say for differentiating a cat and a cow, it is very easy. Both are extremely differentiable. In that case, you can go for a normal machine learning application. Deep learning is the advanced representation of machine learning concepts. So how am I going to differentiate this? So I am framing an architecture. I am giving the input images, and this is the CNN architecture. It itself will determine the feature maps, convert 2D into 1D, and it is going to give me a final result, whether it is COVID-19 or pneumonia or not. So experimental setup. So whenever you work with AI and ML, artificial intelligence and bio applications, keep in your mind, you should be good in some software and you need a computer, nothing else. You can even sit in your home and do the work, right? So these are the software and the specifications which I have used, and I have used Python, but if you're good in another software, you can use that too. And this is the Python program. Maybe I do not have time to explain this program. If you want, you can always inform me so that I can guide you. This is the representation or Python language representation of all the theoretical concepts which I gave you just minutes back. You have a convolution creation, you have a max pooling operation, you have a flatten, you have a dense activation, dropout. All these are informations which we have seen just before. And finally, you will get an accuracy. And the performance measures for all bio applications, right? Whenever you do with pattern recognition, we are now concentrating on pattern recognition applications. So performance measures are precision, recall, F1 score, accuracy, and specificity. It is something like when you are students in a class, how do I pick the best student from your class? I need to have some performance measure. In the same way, when I have a machine, when I give some data for it to identify what is what, when my machine is giving some result, I must be in a position to check whether it's correct or not. So for that, we make use of all these performance measures. And finally, I will get the results in the form of tables. Whether my original image is a SARS image or a COVID image or any other type of image or a pneumonia image. Right? So depending upon the percentage which I'm going to get, I will be easily able to identify, okay, this is so and so. It will help the doctors or the physicians to take an accurate decision. My algorithm will be available in a computer, which will be connected with the scan machine. So the scan will take the image, come to the computer, give it to the algorithm, and it will give you a decision, and the doctor will take a report in the form of a printout and over to you. This is the application-wise setup of such type of pattern recognition. You will get some graphs which will show you the loss, how it is decreasing, or the accuracy, how it changes. This is the result for another method. And these are the results for different methods. So whenever you are doing some project work, make sure you do not stop with only one method. You need to do at least 2 to 3 methods and just compare how one method is going to behave in a better way than another. This is the second one. Again, COVID detection. So if you are not comfortable with the first web page, you can go to this web link and again you can download the images. Not only COVID images, you can also get the types of pneumonia images, bacterial pneumonia and viral pneumonia. So the treatment is going to be different for these two types. So doctors, they are saying nowadays TB is going to come back, and it is going to come back with a different version, which will be very, very difficult for people to tolerate that. That's why people say no to antibiotics, because antibiotics will become resistant, or the disease will become resistant to the antibiotics. So how you can identify? As a person working in AI and ML, you can help the physician to diagnose the disease properly. So these are some of the results. Maybe if you want to have a detailed discussion, I am always ready for that. This is the third work where you have CT images. The previous images are X-ray images. These are CT images. Even you can work with COVID CT images. And the fourth work is you can also develop machine learning algorithms or deep learning algorithms for predicting the number of cases. You would have seen in paper, they will be advertising it is going to peak in October and then drop down in November. IIT Kharagpur, they developed some models. So in the same way, you can also develop some models. But the risk is when you submit some research work to journals, your work will become live, because the January relevant data will be available with them too. So they will compare with your result and the real-time situation. If it is wrong, then people are not going to accept you. It depends upon you which way you want to go. The second work is a diabetic retinopathy work, where you can also make a machine identify the different types of diabetic retinopathy images. Retinal diseases or eye-related diseases are another serious issue in bio applications. Right? You go to hospitals, you can see plenty of people, diabetes people, they will automatically affected by diabetic retinopathy. But the drawback is it is very gradual. You will not be able to easily identify, okay, this is going to be diabetic retinopathy. We have glaucoma, we have age-related macular degeneration, we have optical disc orientation, we have lesions, we have blood hemorrhage, many, many different types of eye abnormalities are there. It is not visible, it is very gradual, that's why it is very, very dangerous. You can also make use of machine learning algorithms to classify them, to categorize them. So for that, the first thing, this is an example for a retinal image. This retinal image should be divided into many different classes, or we can say that this image should be divided into an R plane, G plane, and B plane, red, green, and blue, because you cannot see the blood cells clearly in this image. But when you split into RGB, there is a better chance your information will be clearly visible in the green plane or the green channel of the image. You can see here blue, green, and red. Right? Green is the best one. So when you make use of the green image, your machine is going to take a better decision. These are some of the results from our research papers. And the next one is brain image classification. You can use it for brain image classification too. So these are real-time images which are collected from some scan centers in Madurai and Coimbatore. These are all tumor images, real-time patients' tumor images. You can see the tumor portion here. This white portion corresponds to the tumor. Now you need an algorithm. The radiologist who is there in the scan center is going to finally give you a printout, but he will have an algorithm which is going to say that, okay, this is the tumor portion, or this is the type of the tumor portion. So again, the same deep learning models, the same algorithm. If you are good in programming, or you can get the help of a programmer or a programming student, and you people can join and make this. And this is used for blood cell images also, blood cancer images. Leukemia, non-Hodgkin lymphoma, Hodgkin lymphoma. These are different types of blood cancers which are predominant in India. In that case, how you are going to differentiate the types? Right? That is very, very crucial in determining the treatment planning. Again, if you wonder whether I will have any databases, there are plenty of databases where you can download the images, right? These are links, and you can also approach some hospitals who will be ready to work with you. And this is the process. When you look at the process is same. The same convolutional neural network, pre-processing, some training and testing, training the algorithm, training the method with some algorithm, and then we go for testing, then calculate the performance measures. But the process in which you are going to do depends upon the images. And additionally, you can do another process called as data augmentation, because when your abnormal blood cells are in the form of circles, you can rotate them, zoom them, flip them, and try to get several representation of the original images, so that the decision making will be better. All these things we do to make that machine take a better decision. Same CNN, same comparison, everything. Alzheimer's disease calculation, that is also possible. You have a database called as ADNI database, Alzheimer's disease neuroimaging initiative. You can go there and you can download your data too. These are images, but you will not be able to find out whether the patient is suffering from Alzheimer's or not, but only your algorithms can tell you whether the patient is suffering from Alzheimer's or not. That's why we depend a lot on computer-based algorithms or methods to go for bio applications. And this is the last one, gastrointestinal disease segmentation, right? Polyp cancer. In your intestine, there may be a small plis or a pulp-like structure which may grow or grow bigger in size. Sometimes it may be a normal tumor, but sometimes it may be cancerous, it may spread. For finding that also, we can make use of convolutional neural networks. You have lots of images, you supply and do the same process, and it will try to zero down on the specific portion of your abnormality. Once the doctors are able to find out the abnormality, they can easily do that. Nowadays, people are having pills where when you swallow the pills, it will take the video and images of your complete gut or the intestine. So when they take, they will be able to find out the pictures of your intestine. Then they give it to the machine learning algorithms, where it is going to say whether it is tumor or cancerous or what is the size of the bliss, all those things which a human eye feels difficult to. So these are some of the works which we have done. Possibly, maybe if we have an offline chat, I can support you more. So finally, we come to the conclusion. So we saw the origin of AI. We saw one specific method of machine learning, and we saw many bio-related applications where we can make use of this type of machine learning approaches. But the point you have to keep in your mind is we are trying to make machines become more like humans, isn't it? I want to have that machine completely living like me. But the question you have to ask yourself is, when are we going to make humans more human? You see the news, or you hear the news of Third World War between Russia and Ukraine. We do not know what is going to happen in the future. It is not only important in making machines, but we need to refine ourselves. Good attitude, good ethics, good character. That is what is going to make a human being. Not your degree, not your knowledge, or not your efficiency in the scientific. Hope. When you try to put your hands into these concepts, you will do all these things with some ethical values. And these are my details. My email ID, if you want, you can note down my WhatsApp number, my webpage, and you can have some interaction in LinkedIn also, which is a good platform for all the students, where there are plenty of internships possibilities are there. Right? In that network also, you can have, if you want to have some books written by me, you can also check in Google, where you will get more information, because 1.5 hours is very difficult to give the complete information. Gradually, you need to get into that. Thank you very much. Thank you for patience listening. We have another 5 minutes. Possibly, if there are any questions, I can take this time to answer questions.
Thank you very much, sir. It was really a very wonderful session. Participants, the session is open for questions. You can ask, clarify your queries with the resource person.
Sir, can be, Sumita is asking us, sir, can the genetic mutations be classified? Yes, exactly. So remember, deep learning methods are only computers. They will look everything as numbers. I showed you an image of a dog and an image of how the computers see. I see it as a dog. I see it as a mobile and all those things. Computers will look at only at numbers. So it doesn't matter whether you have a genetic mutation image or where you have the codings, right? If you're in bioinformatics, you'll have that mutations X, Y, Z. All those things can be easily classified using deep learning methods, because it is going to take anything in the form of number. Based on the breeding family history and factors. Yeah, you can also, I have described the methods with the help of images, but you can also do the classification with the help of numbers. But number is a simple data than image. Image is a complex data. Can you tell me why? Any rough guess? Computers will understand only numbers. So when you already have the data in the form of numbers, you straight away give it to the computers. Easy. But when you have it in the form of an image, first you have to convert it into features. That means it into numbers and then give it to the system. Right? Deep learning is suitable for complex data. So if you have your input data in the form of numbers, you can very well go for the normal artificial neural networks only. There may not be any necessity. I am not saying you should not go. There may not be any necessity in going for such complex process. But if you say that, sir, I may expect some better accuracy, then definitely you can.
Any other questions? Participants, you can unmute yourselves and you can shoot.
Yeah, you can unmute your mic and you can ask too. I think there are no more questions, or sometimes you may not feel comfortable in asking a venue, right? If you want, you can let me know at any point of time. I will try to support as much as. Thank you very much for your patience.
Thank you. Thank you very much, sir. It was really a very wonderful session. Thank you, sir.
Thank you.
Participants, you can please fill in the feedback form. The feedback link is posted in the chat box. So on behalf of the organizing committee, I would like to thank all the participants for your patience listening and for participating for the past 2 days. Wish you all the best. Please fill the feedback form and then you can leave them. Thank you very much.